All right, ladies and gentlemen. Questions before we get going today? Well, I don't know because I can't hear you because I asked to get started, but people are still talking, and that's kind of rude. But okay, what's your question now, Cynthia? Okay. So today, ladies and gentlemen, you are going to do your lab. This is what the results of your lab will look like tomorrow. So you cannot get the final mass until tomorrow. So take out your computers, open up to the lab today, ladies and gentlemen. So Google Classroom, actually you're going to open up two forms, ladies and gentlemen. You are going to open up the limiting reactant lab data table. I don't know why someone's turned it in. I'll turn it back to you because you're not done with it yet, so you still need it. Okay? And the other one that you are going to open up, ladies and gentlemen, is the actual half-life or limiting reactant lab that is right below it, ladies and gentlemen. So you need to open up both of those things. Now, please remember, down at the bottom of the precipitate lab, there is the information for second period post-lab discussion. This is what you filled out yesterday. You still need to fill in this part, which you cannot do until tomorrow. Okay? But the rest of this is filled out for you. Tomorrow you will fill out this part. Tomorrow, my fourth period class will fill out their part of this, and then we will get a class average for you guys tomorrow in class, and then we will get an all-class average for everybody tomorrow by the end of fourth hour. Okay? So please keep that in mind. Okay? Once they get their information in here, I'm going to lock the assignment so that you can then make your individual graphs from it. I'll repost it out there as a copy for each of you eventually. Okay? So you can't do anything with that until then, ladies and gentlemen. All right? But today we got to get the lab actually finished. So we are going to experimentally determine the grams of precipitate in a double replacement reaction shown below and find the limiting reactant in each trial. You've already done that. We already know which one is the limiting reactant, ladies and gentlemen. So, the steps to our procedure. You are going to obtain a 150 milliliter beaker and you're going to put your name on it. If your beaker does not look clean, I would recommend cleaning it first. You don't want anything in there that will contaminate or add mass to your sample. So you can clean it, you can go to a sink, you can wash it, you can dry it, you can put your name on it, and then take the mass of it after you have put your name on it. Okay? Yours and your partners or yours and whoever you are working with. There are 18 people here today. That means there are going to be 9 groups of 2. No one should be working in a group of 3 because we have an even number. So if your partner is not here yesterday, you'll have to partner up with somebody else whose partner was not here yesterday. Okay? So keep that in mind. You also, ladies and gentlemen, after you find the mass of the beaker, you are going to find the mass of a piece of filter paper. Those will go down in this table here, ladies and gentlemen, under quantitative data. By the way, every one of these needs a unit included with them. There are no units listed on this table. So you are going to include the unit. You are going to begin with your volume of sodium iodide. Okay? You are going to begin with your volume of sodium iodide. Now, if you are working with somebody today who was not your partner yesterday, and you have a different volume than they did, okay, you are going to have to pick a volume based on the station that you work at that you are going to do. All the calculations are done. And I will let you in the calculation section do your calculation based on the volume you had yesterday, even if it doesn't match this one. Okay? we'll get to those calculations tomorrow. Okay? The mass of a beaker with your name on it, the mass of a piece of filter paper. Tomorrow you will find the mass of the dry lead iodide, the beaker, and the filter paper. So I would take this whole thing, go up to a balance tomorrow, put it on there, and find the mass of everything here. Then, ladies and gentlemen, I could take this mass tomorrow minus these two masses, and that will give me the mass of the dry lead iodide only. That is the one that you are trying to find. That is the one that you will put into this table tomorrow. The mass of the dry sample only. Questions? Okay. Now, okay. Using a clean 10 milliliter pipette and bulb to be used only for the lead nitrate solution. Measure out exactly 10 milliliters of well-mixed lead nitrate solution and add it to your beaker. So the lead nitrate is the one with the green pipette bulb. The pipette should be this bulb should be all the way down. That white handle should be all the way down. When you put it into your solution, ladies and gentlemen, let's practice good lab behavior, including lab safety, ladies and gentlemen. The way it works, ladies and gentlemen, the green bulb goes in the one with the green writing on it. Okay? That is the only place you put it other than back on the paper towel. So, this is marked out. It goes from 9 to 0 on one side. It goes from 1 to 10 on the other side. By the way, if you go up here, you are going over. That is why it goes 10, 11, 12, okay? And it goes into minus numbers here. We want exactly 10 milliliters. You put it into the container. You twist the dial. That will cause this white handle to raise up, and that will cause the solution to go up inside the tube. When you get to exactly 10, ladies and gentlemen, you're going to take this, you're going to hold it over your your beaker, and you are going to press the top of this lever and let it go until no more comes out. That's 10 milliliters exactly. Now, before the next group can use this, you have to take this and push it down. Because if you don't, it's limited how far it will go up, and it will not pull up another 10 milliliters. Okay? That's what they're telling you to do here. Now measure out your assigned volume of sodium iodide with the pipette and bulb to be used only for the sodium iodide. That is the red one. And add it slowly to the beaker with the lead nitrate solution. So you're done with this, you put it back. You now take this one, ladies and gentlemen. Now, depending on what volume you have, you may only have to use 5 milliliters. You may have to use 5 and 10 to make 15. You may have to use this twice to make 20. You may have to use this 3 times to make 30. Or twice and 5 to make 25. I'm not telling you anything you don't already know how to add to 25. This one works by squeezing the top bulb. It takes the air out of it, so that now when you put it in here, there is an arrow on the top here that points upward. When you squeeze it, it will pull up the solution into the pipette. If you get too much, you hit the arrow going down. When you get exactly the amount you want, you go over to your beaker and you press this arrow going down. It will empty out just like the other one. And the last tip of here is accounted for. So you are emptying it out all the way until it is empty. If you need to pull up another 10 milliliters, you put it back in. You press this button. You get another 10 milliliters or whatever you need. You put it over your container. You hit the down button. Do not pull the solution up so far that it gets in this bulb. Do not do that. By the way, if you're pressing this button here and it will not go up anymore, re-squeeze the top bulb. You probably put all the air back into it. Okay? Questions? Now, remember yesterday, when this stuff is in your container here, swirl it around a little, mix it up, and then let it sit. We want the precipitate, the heavy yellow stuff, to go sit on the bottom. We want the water to be on top. Now, while you are waiting, ladies and gentlemen, you can grab your funnel and your flask. You can grab a piece of filter paper, which are out on the back station here, ladies and gentlemen, along with the glass beakers. You grab one, and after you have it masked, you fold it in half twice. Once in half, twice in half. You take your water bottle, only using deionized water. Now, you wonder why we use deionized water, ladies and gentlemen? Here is why. In this lab, we already have ions running around in solution. Sodium and nitrate. We don't want any more ions running around. We don't want chlorine or fluorine ions that are in our drinking water. So we use deionized water. You will see 4 folds when you look at it. 3 of them go towards you, 1 of them goes away. Push this so that it is down in as low as it can go, and then wet it down completely. That will get you a good seal. That will also make it stick to the sides of the glass so that as you're pouring, it doesn't get in your way. Pour slowly. If you put too much stuff in there, it will gum up the filter paper, and then your ions will start sneaking around the filter paper and end up in the bottom, and you will have to start over again. Pour slowly. Don't overload it. One of the best things that you have going for you is letting it sit and settle out. So don't rush to pour it. Okay? Let it sit, let it settle out. When you are pouring it, ladies and gentlemen, you're pouring it and you're watching for all of the heavy stuff on the bottom to start working its way up to where it is going to start coming out. By the way, all of them have a lip to pour with. Pour in that area so that we're sure we hit this. Okay? When the heavy stuff starts to get near the edge, turn it back up. Let it go sit down, sit in the bottom. Take your water, wash it down. Again, don't use a lot of water because you've got to get rid of it, but use some. Swirl it around, let it sit. This will start dripping through. That'll be sitting there. You can literally start working on your calculation. You've got them done on paper. You need to type them in after the lab. Okay? So, get as many rinses as you can done. As many rinses as you can. So you add some water, you let it sit, you let it settle out, you pour. You put it back down, you add a little more water, you let it sit for a while, you pour. When you are done, ladies and gentlemen, completely, you will take the filter paper out of there, you will put it in with your sample. This will still be wet. As little water as possible in here. And then what you'll do is you'll bring it to me and I'll put it in the drying oven for you overnight. And then tomorrow when you come in, I will have them sitting out on the lab table in the back. You will find yours. You will go up to a balance. You will measure it. You will put it in that table and you will record your final observations. Okay? So that is what the procedure tells you to do. That is what you are going to be doing. Okay? So, wait a couple of minutes, allow the precipitate to settle. This would be a good time to record the observations in your lab. Set up the funnel with the filter paper so that it'll drain into an Erlenmeyer flask. After it is settled, you start to decant it a little bit at a time. Okay? Rinse it down, stir it, let it settle. Repeat steps 8 and 9 over and over again. Carefully remove the filter paper from the funnel, place it in the beaker with the precipitate, and we will put it in the drying oven overnight. So, just so that we are clear, 3 observations minimum of the lead nitrate, 3 observations minimum of the sodium iodide, 3 observations of the reaction when you mix the two together. Do not reach your finger in and touch things. Why? We have measured very carefully how much is in there. You get it on your hands, that's your mass that you're losing, that you're getting on your hands. So you cannot use your sense of touch. You can use your sense of smell, you can use your sight, you can use your hearing, things like that. No touching, no tasting today. The wet PBI2 is the solid stuff that is down in the bottom of the container. You will describe it. So the reaction is when you mix the two solutions together. The wet PBI is the stuff that is in the bottom afterwards. You cannot do the dry PBI until tomorrow. Again, 3 observations minimum. Tomorrow, after you mass it, you can touch the stuff. Okay? But not until then. And please make sure you get all the quantitative data except for these last 2, which you cannot get today. Questions? Yes. Okay. I don't have any right now, so hold on. This table here we will replace with yours tomorrow. We will take this one out. You're not going to copy your numbers into here. We're going to take this out. We will copy it out of the lab tomorrow. Okay? We'll copy it out of the lab tomorrow. All right? We will eventually make a graph of this information. And we will put it in there, but we cannot do that until tomorrow. You can start doing these questions, these calculations. We all started out with 10.01 liter of lead nitrate. The molarity was 0.500 molar. You could tell me how many moles that would be. You could tell me how many moles of sodium iodide you had by going into this calculation and changing this from your volume to the actual number that you use. Okay? And then type in an answer here and here. Don't forget units. Calculate how many moles of lead iodide should have been produced in each trial. So now you need to change this to be your ratio step. Don't leave it moles of product over moles of reactant. Tell me what the moles of product are. Tell me what the moles of reactant are. And then tell me what you get here. Now, you need to do that for all 6 trials. But guess what? That's done for you. That is done for you in that table. The numbers are there. All you have to do is copy them in here below. Okay? And please remember, you can only make which amount? The smaller amount. Okay? Calculate the grams. How? By taking the moles of lead iodide that you got in the problem above, formula mass over 1 mole. Again, change this. Don't leave it as formula mass. Put the number in here. Show me what you get. And again, the answers for all of these are already done for you. All you have to do is copy them off of that table. And then, ladies and gentlemen, you will do a percent yield for all 6 trials. You will take the experimental value divided by the accepted value. You cannot do this tomorrow until we get our class averages. Because you will take the class average divided by what you are supposed to get. Times 100, you will do it for all 6 trials. And then there are some questions that we will talk about. Actually, you could probably do them even today if you really wanted to. So you're going to have a lot of time on your hands today while you're waiting. Use it wisely. Questions? Goggles are in the back. Please remember, go to the station that has the same color card that you worked at yesterday. There is a reason for them to be set up that way. So please go to that station. Either side doesn't matter as long as you're at your right color. Two charging blocks, ladies and gentlemen.
It's supposed to be super stormy. It's supposed to be really stormy for our this Saturday.
If it rains, you guys are gonna get so how do you know if it rains? It's supposed to rain.
Yeah. Like, highly likely. I hope we get rained out for our game on Saturday. No, it's on Saturday game.
Oh.
No, it's like storm. Oh, like thunder and lightning.
Like Saturday, Sunday. It was thundering.
Was it?
Yeah.
Wait, what?
At least here was.
This last Sunday?
Yeah.
Oh, yeah, it was raining.
Like for like
It wasn't bad,
3
though.
seconds.
Yeah, it wasn't bad here.
Get your goggles on, ladies and gentlemen.
Outside while it started pouring.
Oh my gosh, it'd be so bad. I was at work, so I did not care.
Lucky you. I didn't eat that
You were golfing? Oh my god.